Share the screen.
Yeah. I'm just going, before John starts with his part of the meeting, I'm just going to share with you the usual welcome slide and a few words about Cement and Concrete SA. Let me just get it up, and then I go into mode. So everybody, welcome to Cement and Concrete SA, the first concrete fix for 2022. And what was started during the COVID time in 2020 as a quick reaction to the lockdown to have Zoom meetings has now found such favour by our members that we've decided this year, even though we're going to start at branch level to open up with more physical events, we will continue with our concrete fixes at least for this year. And we're planning on having one every third Thursday of the month. So we're planning to have one a month. So keep your eyes and ears open for the notifications of these Zoom meetings. Cement and Concrete SA leads through unity, relevance, and leadership. And just a brief note on our members, our partner members, AfriSam, Lafarge, PPC, and Sapaku. Our gold members, SEMSA and CRISO. Silver members, Gioli Readymix, CoreStruck, the Quick Group, and Seeker. And then we're very thankful for 24 bronze members. I'm scrolling through their logos, you can see who they are. And more, 24 bronze members. Associate members, there are 6 of the associate members already on board, and it's very nice to have these reciprocal arrangements with other bodies. And then our academic members, it always gives us a pleasure to have our academic members, and not only the lecturers and the researchers at the tertiary organizations, but also some of the students on board. We welcome them all here with us today. In brief, I want to encourage those of you who are watching today but have not yet joined Cement and Concrete SA to become a member. There are so many member benefits, not only for the companies involved in terms of your logos on display and hyperlink to your websites, but also for individuals, the discount on courses, discount on consulting services, and many more. Please talk to Natasha Poss if you want to know anything more about membership. But I really want to urge you, Cement and Concrete SA was formed last year, March 2021, and I really think I'm not wrong in saying that in the past 10 months, we've showed that we're adding value to our industry. We've showed that this is a body to be reckoned with, and we want to encourage you to look at your membership options. There's a wealth of information available on our website, semcon-sa.org.za. We're on LinkedIn, and many of our notices will go on LinkedIn. Please follow us there. And we've also created an Instagram account, and our Instagram name is Cement Concrete SA, all one word. So please follow us on Instagram to look out for the latest information. Concrete Beton, our quarterly electronic journal, is available on the website. You can read it there. And this year we're planning really a good spread of articles in Concrete Beton. And the good news is that the June issue, which will coincide with the Fulton Awards, will actually be a print issue as well, because we always believe that people want to see the print edition, and we've decided to make the June issue not only electronic, but a print issue as well. So keep your eyes and ears open for that one. If you remember, you will receive a copy of the print issue in the post. Non-members can read it online. Many of our concrete fixes this year will actually be based on chapters in Fulton's concrete technology. Now, for those of you who are familiar with Fulton's, it is the definitive handbook in South Africa on concrete technology. And we thought that it would be wise, it would be prudent for some of our authors to share a bit more than what is just available in the book. But remember, what you see in a concrete fix won't give you everything. So please make sure that you obtain your copy from the Information Centre at Cement and Concrete SA. Our School of Concrete Technology is up and running. During the lockdown years, they did all their courses online, but they're opening up again. So there's going to be some physical courses, some online courses. Please make sure that you refer to the latest education program on our website that will give you the dates and the listing of courses that are available. And then just a word about the CPD points for the concrete fixes. All our concrete fixes carry CPD accreditation, but unfortunately there's been a bit of a delay on the side of the current accreditation body. And Natasha has been told that this will be rectified in February. She will inform you all as soon as this has been resolved. Bear with us, but we are getting the CPD points for the concrete fixes, the last couple of them from last year and going forward this year. Remember, if you wish to get your CPD points, make sure that you've sent an RSVP to Natasha Pulse with your details. She will not be able to give you the CPD points afterwards if you've not sent her your details. So please make sure that you get in touch with Natasha. And then the good news. On the 17th of February, next month, 10 o'clock in the morning, there'll be a site visit arranged by the Inland Branch to the Vlakfontein Reservoir in Benoni. You will still see the invite going out next week. It will give you the detail as to where you can book. There will be limited seats available, so keep your eyes and ears open for the invitation to this branch visit, site visit. And then that afternoon at 3 o'clock, we've got our second concrete fix for this year, and the speaker will be Mike MacDonald, talking about his chapter on control of concrete quality and quality systems. So 2 exciting events coming up in February. Cement and Concrete SA, we're building a future together. So please make sure that you update your membership. Later, in a couple of months' time, Natasha will be sending out membership renewals for those who are members already. If you're not a member, please get in touch with Natasha and make sure to take up membership of Cement and Concrete SA. So that is just by way of introduction. But I'm really thankful today for John Roxburgh, who's agreed to do the first concrete fix for us this year. And John is going to be talking about his chapter in Fulton's Concrete Technology, which is mixing water. Just a bit of background about John. He's a technical specialist at Cement and Concrete SA, and he holds a BSc in Building Science from WITS and is a member of the Institute of Concrete Technology in the UK. After completing his building science degree, John worked for LKA Building, where he gained extensive experience on various contracts. Before joining TCI, John spent 6 years as a technical manager in the brick and block manufacturing industry. John was awarded his ACT diploma in 2013, and he has a keen interest in all facets of the concrete industry and is especially passionate about concrete technology education. So without further ado, John, you can start sharing your screen. And I will just remind everybody to please mute your microphones if you're not muted already. John will start sharing and he'll present to us. Thank you, John.
Thanks very much, Hanelie. Is my sound coming through all right?
Your sound is coming through and we can see your slides. Thanks, John.
Right. Good afternoon, everybody, and thank you very much for the what I think is an excellent attendance. I was speaking to Hanelie earlier, only expecting about 10 to 15 people for this dry subject of concrete mixing water. All right, this presentation is based on the chapter 5 in the Fultons, and it's a chapter originally written by John Goodman. So I just had to review and sort of upgrade it. So I want to give him credit for a lot of the work that was done on that chapter. It's funny, I'm about to tell you how scarce good water is. But I traveled up from KwaZulu-Natal yesterday, and every single river I went over that burst its banks. There's water everywhere, and you can't believe that we could have scarcity of water in this country. But anyway, I'm about to show you why we could. All right, so mixing water for concrete, we always taught all our courses that we go on, we taught that we want potable water, water that we can drink, municipal water. That's the water that we want for concrete. So fresh, clean water. And I'm going to talk about fresh, clean water now in the next few slides. But that's really what we're aiming for. But are we really aiming for that? I think maybe there is, after this presentation, you'll see there is scope for not always using fresh, clean water. Right, so this is a slide that I'm sure most of you have seen. It's all over the internet. So some scientists got together and they took all the water in the world and they put in a ball, and you can see that ball. It's sitting over North America there. So the water covers the Earth. 71% of the Earth is covered by water, but it covers it very, very thin. And if you take all the water, you put it in that ball, you can see how much water there is. Next to that big blue ball is a slightly smaller ball, or quite a lot smaller. And that's the fresh water. Remember, I told you we want fresh, clean water for our concrete, mixing water. So that's all the fresh water in the world. And you probably won't be able to see it so easily, but there's a very slight dot below the second biggest one. My cursor is on it. If you actually look at the bottom of the slide, you'll see the little light dot. That's all the water that's sitting in our dams, reservoirs, and lakes, and rivers and swamps. And that's the water we use for our concrete. So you can see there's very, very little, considering water, available for use by human beings. Let's look at those numbers. About 2.5% of all Earth's water is fresh water, only 2.5. And of that 2.5, 0.3% of that 2.5 is found in lakes, rivers, and swamps. And this is the water we use for our concrete. And making matters worse, 87% of that 0.3% of fresh water is held in the great continental lakes. Every continent has these big lakes. For example, in Russia, the Lake Baikal contains about 22.6% of all the available fresh water. So there, the last point, Africa, its Great Lakes has 29% of that 87%. So you can see there's very little other water. We don't have access to the Great Lakes. And it's quite interesting in Africa, the African nations sitting around the Great Lakes in Africa are very susceptible to famine and droughts because they don't have an infrastructure to get hold of that water that's sitting right next to them. So also important for countries and for South Africa is an infrastructure that can deliver the fresh potable water to the concrete producers and to the people. So let's talk about fresh water in South Africa. South Africa is a water scarce country. This slide, I actually, I didn't take it from, but I got the information from a paper done by Professor Anthony Turton. Our annual rainfall is about half the global average. So our annual rainfall sits between about 450 and 500 millimeters. And the average in the world sits somewhere between 900 and 1,000 millimeters per annum. So we don't get a lot of water, okay? And added to that is there's increasing eutrophication and pollution, along with the problems associated with climate change. And this all can add to the scarcity of the water. But as I say, not at the moment, but at some points we could get that. And then in Cape Town, we saw in 2017, 2018, there was a drastic shortage of water. So don't think that we are safe. In 2025, if the economy grows in SA, which I don't want to say it's a good thing, but it hasn't grown because this report was done in 2012. But if it had grown, we would have been about 2 billion cubic meters of water short a year. So I don't think it's going to be as bad as that when we reach 2025. But if the economy does start growing, we are going to find that we are short of good water. So I just want you to remember this. In South Africa, rainfall, precipitation is the foundation to South Africa's economy. Our economy is based on water. Every single agricultural, industrial, business process needs water. And this Professor Anthony Turton also says it needs water for the manufacturing, but also the rainfall is there to also flush the systems. So we're very thankful for the rain that we had now, because all the failed sewage plants and things like that have all the dirt and the waste is flushed out of the system through rain. So we're very dependent on rainfall. So we just keep that in mind. So freshwater and concrete producers. Definitely concrete producers could come under increasing pressure to use non-potable mixing water. And we did see that in Cape Town 2017 and 18. And not only due to the scarcity of potable water, but for ethical reasons too. So in the name of sustainability, we maybe want to start using more non-potable water, more wastewater. And wouldn't it be wonderful if we could get greenie points for actually using water that we can't use for drinking? And I think that we could see more of that. Interestingly, in 2017 and 18, and this is why I'm not too worried, but 2017, 18, I expected to get more phone calls from Cape Town with people saying, what can I do? I haven't got water to produce my concrete. And in those 2 years, I only got one phone call. And that was from somebody who wanted to plaster his house, and he wanted to know if he could use his swimming pool water to mix into the plaster mix. So I'm not really convinced at the moment for the next few years that we will be short of good, clean, potable water. But please, if you are producing concrete, consider trying to use a waste stream somehow. But let's get on to the mixing water in concrete. I just put this up for a bit of fun. What is concrete mixing water used for? So when I put up this, when I was writing up the slide, I could think of 6 things off the top of my head. I'm sure there are quite a few others, and it would be quite nice if you guys, if you could think of other ones, you could put it on the chat. But just quickly think if you can think of at least 6 different uses for the mixing water in concrete. Why do we use mixing water in concrete? So just think of it, and I put up the list that I came up with. All right, let's go. All right, so I think the biggest use is, of course, the hydration of the cement, and that I also want to include the facilitation of the chemical reactions between the binders. You know, the different additions or extenders that we add into our cement. So we need that to form the cement gel, the glue that holds everything together. And then, of course, another major thing is, of course, it's the major lubricant in our concrete. It's actually this slide is something that I ask people. I get people phoning and saying, I want to do the advanced concrete technology course. And I always give them this question. I say, well, what is water used for in concrete? And they usually just come up with the first two. They can't come up with any other. But if you are at the stage where you want to do advanced concrete technology, you typically would be able to come up with these, with the basic concrete training, these reasons for using mixing water. Cooling concrete and heating concrete, they basically go together. We all know that water has a very high specific heat capacity, about 4,184 joules per kilogram Kelvin. So it's got a wonderful capacity to heat up or cool down that concrete. Your aggregate, your stone, your typical rock only has a specific heat capacity of about 2,000 joules per kilogram Kelvin. So it's an excellent heating and cooling aid. Admixtures, they can be very reactive. You never want to put your admixture straight with your binder because it will latch onto the binder that it meets first. So you want to disperse it as quickly as possible and evenly as possible through your mix. And your mixing water is used for that, for dispersing admixtures. Excellent disperser of admixtures. And then another one that I came up with is, with industrial floors, these big open, vulnerable sections of concrete, vulnerable to drying out. A little bit of bleed water coming to the surface will stop plastic shrinkage cracks and early age cracking in its tracks. So always consider that a use of mixing water. So I'd love to see other people come up with any other uses for mixing water on the chat. Right, so impurities in our mixing water. If we've got impurities in our mixing water, we must have sufficient quantities of them to make a difference. But if we've got sufficient quantities of them to make a difference, these are the things that can go wrong. So they can, and this is the first one, alter setting times. That is something that can occur quite often. So they can alter the setting times. The fine materials in the water can increase the water demand. Things like algae and organic matters can entrain excessive air into our concrete, and we all know that air in our concrete leads to a drop in strength. It can change the strength gain properties. In other words, it might take longer to gain strength, or it might gain strength a lot faster, but not end up with its potential strength. Later on in the concrete, we can get degrading happening in the concrete, sulfate attack, alkali silica reaction. Chlorides facilitate corrosion of the reinforcement. And staining could happen as well. There's stuff in the mixing water that can stain the concrete. And the last one, I can't read it because something's hiding it, but I think it's efflorescence, the architect's nightmare, efflorescence. And in this case, it would be the leaching of salts out of your concrete, staining the surface. And I've never got a problem with efflorescence because after a couple of rainy seasons, it's usually gone. But anyway, efflorescence is something that can happen due to your mixing water. Right, so it's a bit of a tongue-in-cheek slide that I put up here. So mixing water can cause havoc with your concrete. And I asked the question, really, can it? And what I'm trying to get at here is that don't stress too much. I think a lot of people stress about the mixing water, and most times the mixing water will be fine. So I'll put up a couple of slides here to show you why I don't think you should stress too much. But having said that, always be careful with your concrete. All right, so when I was asked to review the water chapter, I thought I'd read extensively about mixing water. And Sue, I know you're watching. I went to Sue in the library and I wanted as much as possible of mixing water. Well, can I tell you something? There's almost nothing on mixing water because people don't worry about it. It's not a big thing in concrete production. And I think that there was a little chapter on this, the book by Mendez and Young, the references in the chapter. And they said this, and I think this is the sensible thing about mixing water. They say poor quality concrete is produced more often from adding too much good quality mixing water than using the correct amount of poor quality water. And I think that's the sort of thing that we've got to just remind ourselves about, is that it's not always a disaster if you haven't got fresh, drinkable water. Rather put a lot of emphasis making sure that you get the right quantity, not too much water, than using the incorrect water. This is just an example of if you've got deleterious, bad substances in your mixing water. 2,000 milligrams per liter of total dissolved solids in mixing water only equates to about 400 grams per cubic meter of concrete. 400 grams as compared to 2,400 kilograms. You see, it hasn't got much bang for its bucks. It's you've got to have a lot of impurities in the water to make a big difference. I know if you're a good admixture salesman, you won't say that your admixture, the quantities have to be very low to have an effect. You'll always say you need a lot of your admixture to make a difference to the concrete. Why? Because you want to sell more admixture. But the fact is, you usually use quite a lot of materials to make a difference to the plastic and hardened properties of concrete. Right, so this is another thing that I want you to keep in mind. If the chemical composition of the poor quality mixing water remains consistent, in other words, it stays the same concentration, then the chances are you could design your concrete around the poor quality mixing water. All right, but it must remain consistent. I had a guy once phone me from Mozambique, and he was saying that they were making concrete. They've been doing it for many years, and every now and again, his concrete just doesn't get the strength. It doesn't set and doesn't gain strength. And so I spent about 2 hours on the phone with him, going through every single scenario that he had tested and double tested, and he said it couldn't be that scenario. And so eventually I gave up and said, I can't help you, and I just blamed it on the cement. That's what we always do. We always blame it on the cement. But anyway. But as we were saying goodbye, he happened to mention that he worked for Hewlett Sugar, and there was his problem. So we found out that every time they harvested the sugar cane, his concrete dropped in strength because they were taking the water out of a reservoir that the sugar plantation strained into. Right, so we'll go through a few of the important impurities that we need to look out for in our concrete. So chlorides, of course, I think everybody knows chlorides. We really don't want chlorides in our concrete if we've got embedded steel. And SANS 10100 part 2 says to minimize the chloride content in reinforced or pre-stretched concrete, we need to make sure that the mixing water has less than 500 milligrams per liter. And then, of course, we can't use seawater at all or brackish water. And then your accelerators like calcium chloride and other admixtures containing chloride, we need to make sure that we watch the quantities in those. But remember, it's the overall quantity of chlorides in your overall concrete. So you might have a reasonable amount of chlorides in your water, but if there are no other chlorides present, you might be able to get away, not saying that you should exceed these limits, but just remember it's the overall quantity. And the same applies to sulfates. And then the high chloride contents can also affect the strength of concrete and the strength gain. you often find with glides you get an accelerated strength gain, but your eventual potential strength is dropped a bit. Sulfates. I don't like spelling sulfates like this, but in the Fultons we spell it like that because that's the internationally accepted way. But the British way is spelled like this with the PH. I think we all know sulfate attack. You can react with hardened cement paste, causing expansion and softening and spalling of the concrete. SANS 51008 is the standard for mixing water. And that gives an upper limit of 2,000 milligrams per liter in sulfates. SANS 10100 Part 2, which is basically a guideline, a best practice for concrete works, it limits it to a maximum of 4% by mass of the cement. So we want to limit the overall content of our sulfates. And here, again, we need to look at the sulfate content in our aggregates as well, in the overall concrete. We're worried about sulfates. Sulfate attack you don't want, but if you can keep your concrete dry, you're not going to get sulfate attack. It's just showing what sulfate attack looks like. Right, sugar is a funny one because I think, there's anecdote, people always used to say the guys with the ready mix trucks used to drive around with a bag of sugar and put it in the back if they don't want their concrete to set. In the research I did, there's all sorts of things about sugar, but typically with 0.03 to 0.15% sucrose by mass of cement, it will retard the setting time of the cement. So your 7-day strength may be reduced, but then, interestingly, your 20-day strength may be increased. That second point, greater than 0.25% sugar by mass of cement may cause rapid setting. So it's a little bit confusing. So we really want to limit our amount of sugar in our concrete. And there also a reduction of 28-day strength. So we try and limit it to below 500 parts per million of sugar in mixing water. Generally, you won't have any adverse effects. I think the code, you'll see later, limits this to a much lower amount. But you'll probably find the standard is quite conservative. Oil, mineral oil in concentrations greater than about 2.5%. Mass of cement may reduce the strength by more than 20%. So be careful of oils. If you're using wastewater from an industrial process. Humic matter, and maybe all of us just call it organic matter. It's created by the breakdown of carbon-containing components of animals and plants. And typically they retard setting and decrease the strength gain. And you can look up for more impurities in the chapter 5 of Fulton's. All right, natural waters occurring in South Africa. There was a Bond, not James Bond, but Mr. G.W. Bond. In 1946, he did an intensive survey of all the natural waters occurring in South Africa. And basically, the outcome of that is that most are suitable for using as mixing water and concrete, with a couple of exceptions. Dissolved salts, mainly in the northwestern Cape, they tend to be a very salty water. And then we talked about that earlier. River water in sugar farming areas is not suitable. Remember, turbid water that contains floating solids or solids that are suspended in the water. Clay and silt. Silt tends to filter out quite easily, but clay doesn't settle very quickly. But you should really have a big settling tanks if you're using turbid water to let it settle before using it. Right, so we come to the code that the SANS 51008, and it is the European code. It is the European code 1008. So mixing water for concrete, specifications for sampling, testing and assessing the suitability of water, including water recovered from processes in the concrete industry as mixing water for concrete. And to be honest, I find standards, and they are hectically boring things. You know, anybody who has to work with standards, I feel very sorry for them. But anyway, this code, I can tell you, if you spend, I looked it up quickly before the lecture, 456 Rand, 466 Rand and 55 cents. That's what it costs. It's well worth getting. If you're going to produce concrete, or you're an engineer wanting to specify your concrete, well worth getting this, because it gives you a lovely process of going through your water that you potentially want to use with your concrete. And if you've done the testing and you've done it according to 51008, you can, if something goes wrong later, you can at least say, listen, I did the water testing properly, the water is okay. Just before we get into that, into the actual standard, just talk about the South African standards that point to this mixing water code. So your SANS 2001 CC1, which is basically you need to, it's a requirement. You have to do your concreting, your structural concrete according to this standard. And there it says, water shall be clean and free from injurious amounts of acid, alkalis, organic matter, and other substances that could impair the strength or durability of the concrete or metal embedded in the concrete. And where required, in terms of the specification data, it must comply with the requirements of SANS 51008. So it does point, it says use 51008. Make sure it complies with that. And then the SANS 10100 Part 2, which is the guideline and best practices for concrete, it also recommends, it says water should comply with the requirements of SANS 51008. And if in doubt, we need to specify that it needs to be tested according to 51008. All right, so the code is quite nicely structured. Basically, on the slide, it gives you what the code gives you. It basically says, let's classify the water according to certain things. I'll put up a slide with all the different classifications of water. And then from that classification order, we decide what we're going to do further, whether we need to do further testing. And if we have to do further testing, then we do a preliminary assessment before we go to chemical properties. So the preliminary assessment, if we're okay with that, we might be able to use the water. If we're not okay with that, we might want to go and do some more chemical testing. And then if it passes all the chemical testing requirements, then we can go and check for setting times and strength. And the code tells you how to sample and tells you what tests to do. Right, so this is the classification. Potable water, you see it's suitable. So you would, if it's potable, municipal water, drinkable water, you don't have to test it. You can use it. But if it's, and at the bottom of the slide, I don't know if you can see it, I can't see it, but it says sewage water. And I presume it's, we can make the assumption it's untreated sewage water, okay? If it's sewage water, we reject the water straight off. We never use sewage water, just can't use it. Okay? It's dangerous to use it as well. Going back, water recovered from concrete production, the code's got an Annex A and tells you, it gives you certain limits. And in that Annex A, it really doesn't really give you much. It basically worries about the solid content of the mixing water. It limits that to about 1%, or not more than 1% of the total mass of aggregates. So it sees it as the solid parts as part of the aggregates. But you guys from the ready mix companies, I think you are pretty good at reusing your recycled water, your wash water, etc. I think most good ready mix companies do use it. It saves money, and in many cases it can lead to a strength gain. can give you an advantage by using it. Water from underground sources, you might want to assess it further. And then natural surface water and industrial wastewater, you would also need to just double check by doing further testing, further assessment. Seawater and brackish water, excuse me, you can't use it for reinforced concrete, but you can use it for non-reinforced concrete, but I would do further testing. You want to know the setting time, the eventual strength it gets to, and design your concrete around it. Right, so there's the table. If you have to do further testing, I've just divided by color. There's 3 sections. So you do a preliminary assessment, and that's the table 1. So I'll put up that table just now to show you what's on that table. And then if it gets through the preliminary assessment and you haven't rejected it, you would go and check out the chemical contents of the water and make sure it meets the limits, and there are the limits on the side there. This harmful contamination at the bottom, I'll put up a table showing you those. And then if you're happy with the chemical contents and has met all the requirements, then you would just check the setting times and the strength of the water. So there's a definite nice flow through the standard. So there's the preliminary assessment, and from this preliminary assessment, you might outright reject the water. So you would do certain tests. For example, for detergents, you check if the foam remains, and then you might say, no, too much foam remains after the test I've done on it. After 2 minutes, there's going to be too much air in the concrete. I might as well just reject it and look for other water. So there are a whole lot of things. Interesting here, acids. pH of the water, they basically say anything 4 and above pH. So it can be a little bit on the acidic side, your water. There's no problem, because the whole concrete as a whole is produces a very alkaline environment to negate the acidic environment. Then humic matter, you could also assess the color and the smell, etc. All right, so you then go and do the chemical properties, and you check for your chloride content, your sulfate content. If you've got reactive aggregate, you'd be worried about your active alkali content. And then there are a few other contaminants that they mention. And it's not really clear why they chose these particular ones, but maybe they're the ones in Europe that come up the most often, so I'll bring them up now. Okay, so sugars, you see how they're limited to below 100 milligrams per liter. Phosphates, nitrates, lead, and zinc. So all of these, it's quite interesting that the top 2, sugars and phosphates, and the lead and zinc, they tend to retard the setting and in some cases the strength gain of the concrete. It's just the nitrates and nitrites that we worry about, because they tend to accelerate the setting time. And the guys that work for admixture companies will know that a lot of accelerators are based on nitrates. All right, so the SANS 51008 requirements for setting time. Typically the initial setting time, not less than 1 hour, and there should be a 25% tolerance on when compared to just a specimen made with distilled water. Final setting time, not more than 12 hours, and then of course a 25% tolerance on final setting time when compared to a specimen made with distilled water. And then the strength of the mortar, the requirement for the strength, the mean compressor strength at 7 days. You see, they check it early on. You want to check it early on. Should be at least 90% of the mean compressor strength of the corresponding specimens prepared with distilled or deionized water. Okay. So Annex B in the thing gives you a nice scheme. So if you worried about your water, you go to this Annex B and you test it according to this. Step 1, is it potable water? Yes. Great, accept the water. Is it sewage water? Yes. Well, then reject it, out of hand, don't go further. And you go through this whole thing, it's listed there. I just noticed on this point 5, seawater or brackish water, it says, yes, accept it. Marlies' iPhone was on, okay. I won't say, I was going to say May something, but anyway. Here it says use only for concrete without reinforced, but I would go and do further testing. I would, if it was seawater, I would need to know its setting time and its strength gain properties, etc., and design my concrete around using the seawater. Okay. All right, so we basically come to an end. Yes, it doesn't look like it now, but good quality water will become more scarce. We could be pressed into using non-potable water in the future, and I don't really want to be pressed into that. I'd like to see people using more non-potable water, locking it up in concrete, and you get some good greenie points for that. Concrete always gets a bad rap, and in fact, concrete is one of the most incredible materials, sustainable, low-carbon materials that you can use for building. So we can get some brownie points for that. If non-potable water is used, it must be consistent. In other words, it mustn't change. You guys that ready-mix companies, you're always complaining to the cement producers about variability in your cement. So you know all about that. You don't want your cement to vary because your concrete goes haywire. So it's the same thing with mixing water. You don't want it to vary, and then you can design your concrete around that. Remember that most South African natural waters are suitable. Northwest Cape is not suitable, but just think about where you are and the chances are that you're going to be able to use it. And then if there's any doubt at all, just do the tests according to Sans 5188. I get people phoning me up and saying, can I use this water and everything? Is it suitable? And I say, just go through the process in 5188. That is the process to do, and you'll be fine. And the chances are you'll be able to use the water. All right, thank you very much, everybody. And if there's any questions, please shout out.
Thank you, John. Any questions for John? You can put it in the chat, or you can ask anybody with a question for John. I remember hearing it in my very early days at the Concrete Institute in the early 90s, somebody saying better concrete would be made if we give cement away for free and we charge for the water. And I think what John has just said actually enforces that thing. If we control our water and quantities better, we might come up with really good concrete. John, it seems that you're off the hook. There does not seem to be any questions. So if you would just stop sharing, thank you so much. There's a comment from Susan. The pollution in South African natural waters is much higher than in the past. I would be wary using it without testing. Valid point. Thank you, Susan, for that. Any questions?
Could I just add to that? Yes. Any natural lying water, not municipal water, in other words, untreated water, I would definitely test. You need to sort of assess it properly. Yeah.
Thank you. And John, thank you so much for sharing with us. I appreciate this. Thank you everybody for joining us today. Remember, the recording of the session will be on our website under the events tab latest Monday. So if you've missed some of the points, go and listen to the recording again. And thank you, John. We look forward to seeing you on the 17th of February when we're listening to Mike McDonald. Go safely. Thank you. I've just got one comment, John. Is treated wastewater released into rivers and canals at risk of having too high? Let me just see the, John, can you read the rest of the?
Yeah, so is it at risk at having too high a chloride content? Absolutely. You need to, a lot of industrial process, the chloride content is high. So yeah, you need to test it.
Thank you. If that is it, then we'll conclude the session. Everybody stay safe and hope to see you in person at some stage this year. Take care. Thank you.